Hey, seventh graders, welcome to Module 4 and the beginning of our new unit on ratios, rates, and percents. This week, we're only focusing on what rates are and what unit rates are. And so here are the learning targets. Basically, we want to recognize equivalent ratios, and then we want to be able to make decisions like who's traveling faster, what's the better deal, by looking at how much for one of the same unit. So those are our two learning targets. So rates, a rate is a special ratio, and a ratio is a comparison of two numbers or two things in which the two terms are in different units. Let me show you. 150 heartbeats in 2 minutes. That's a rate because it's comparing two different things that have two different units, heartbeats and minutes. Another rate is amount of money for so many pounds of candy. Money and pounds are the two different units. Here's a rate about a flag football league, 156 players for every 13 teams, players and teams being the different units. Notice I'm writing it as a fraction, and that's on purpose because in a few minutes we'll see that we can compare these rates and work with them by using division. And we know that that fraction bar means division, right? Last example of a rate, traveling 600 miles and using 20 gallons of gasoline. That's a rate in which a car uses a certain amount of gasoline for a certain amount of distance they go. So 600 miles to 20 gallons. Miles and gallons, two different units. Equivalent rates. So equivalent rates are the same comparison of numbers and have the same rate per one. Two rates are equivalent if one can be expressed as a multiple of the other. In plain words, I want you to take this and apply it to your background knowledge of equivalent fractions. You've spent a couple years generating equivalent fractions. That's what equivalent rates are. Take a look at this double number line. In blue, it's showing us that this car can go 112, or it went 112 miles in 2 hours. If it was going at a constant rate, then all of these other rates on the double number line are equivalent to it. So notice the next part over, 224 miles in 2 hours is an equivalent rate to the first one. Okay. And then another equivalent rate is 336 miles in 6 hours, because what's happening here is from this one to this one, it just doubled. From this all the way to this one, it tripled. And as long as we multiply one unit, like miles, by the same amount of, the same multiplier as the hours, we're just continuously generating equivalent rates. Identifying equivalent rates. If a car is traveling at a rate of 30 miles per hour, that's a rate, and continues driving at this speed, what's an equivalent rate to this? You don't have to write out a double number line, but you can apply your background knowledge of equivalent fractions to generate or create other equivalent rates. So I took 30 miles for 1 hour and I doubled it and I got 60 miles in 2 hours. Okay, then I doubled that and I got 120 miles in 4 hours. I hope you're connecting this to the multiplication piece. Then I took that second one, I just multiplied both the miles and hours by 5, and I got another equivalent rate showing it can go 300 miles in 10 hours. Of course, that's assuming that it just keeps going, right, at a constant speed. And I could go on and on and on just by multiplying one of them by the same number as I multiply the other one by. Here's a double number line of donuts compared to the amount of boxes used. So we can see there's 12 donuts in one box. if we had 2 boxes, how many donuts would be there? 24. If we had 3, we'd have 36 donuts. What about 4? Yeah, 48. Do you see the patterns? I could keep going with the patterns, or I could jump all the way to the 10. In 10 boxes, I'm going to multiply by 12, and there'd be 120 donuts. I could fill out any part of this double number line by applying the idea of, again, multiplying one of the units by the same number as the other. So unit rates. Unit rates are ratios that compare X amount of units of one quantity or one thing to 1 unit of another. Miles per 1 hour, heartbeats per 1 minute, and so on. So we calculate unit rates by using division. The candy example. If I know this rate of $6.75 for 3 pounds, then to find the unit rate or the unit price, it's like finding how much does it cost for just 1 pound. Well, I got to break it down and use division. I divide the cost, $6.75, divided by the 3 pounds, and I got $2.25 per pound. That's the unit rate of this candy, or the unit price. Here's another double number line comparing miles and hours, and parts of it are hidden from us, the unit rate, in fact. But we can use what's already there to help us calculate the unit rate. If it can go 120 miles in 2 hours, I'll divide 120 by 2, and I get 60. 60 what? Oh, 60 miles in 1 hour. Oops. Okay. Now, sometimes we're going to be faced with fractions, but we've got this. No worries. The kitchen sink was leaking at a rate of 1/4 of a gallon every half hour. How much water leaked in 1 hour? There's the unit rate question, per 1. Okay, so here's the rate that we know. There's 1/4 of a gallon for every half hour. We use division just like we did with whole numbers. 1/4 divided by 1/2. We want to know the gallons per hour, so we divide the gallons gallons by the time. The order of division matters. Then we have to remember that dividing fractions is the same as multiplying by the reciprocal, or copy dot flip. 1/4 stays the same. Division changes to multiplication. 1/2 flips to 2/1. Then we multiply across. And we get 1/2 of a gallon leaks for every 1 hour. Rob paints 1/4 of a picture in 3/5 of an hour. In how long or in how much time can he paint one entire picture? That's a unit rate question because it's per 1 picture. So we're comparing time to the amount of the picture because that's what the order of the question is labeled as, time to amount of picture. So that's 3/5 of an hour for every 1/4 of a picture. 3/5 divided by 1/4, multiply by the reciprocal, and then multiply across. Simplify if needed. 2 2/5 hours. Let me show you this on a double number line in case you want to use this as a tool. Time on one line, picture, the amount of picture on the other. So the time and the picture are growing at the same rate. 3/5 of an hour is 1/4 of the picture. Then another 3/5 would be 6/5. Then another 1/4 would be 2/4, right? It's growing. Then 9/5 is 3/4 of an hour. 12/5 is 1 full hour. And that's where the answer shows up on the double number line. It's all about patterns. So calculating unit prices. We can use unit rates and apply them to prices to make decisions about what products to buy. So think of that candy example. If at one store, that was the unit price that I got, before, the $2.25, I could go to another store and compare, see if it's cheaper or not based on the unit price. Let's take a look at this yogurt example. And many stores on the labels on the shelves give you the unit price. You have to look kind of carefully. It's small. I challenge you to look next time you might be at a grocery store. Because when you don't really care about the brand, you might just want to save money, right? You just want to go with the cheaper option. So the low-fat yogurt at the top is $1.62 for 32 ounces. So you divide the $1.62 by 32 and you get a unit price of 5 cents an ounce. The one on the bottom, if you divided 72 cents by 6 ounces, it breaks down to 12 cents an ounce. So which one would you buy and why? I'd buy the cheaper one, the top one. Again, if I don't care about the brand or the taste. Okay, let's compare these two products. 12 ounces for 96 cents versus 16 ounces for $1.12. I'm going to divide the cost by the unit of, unit of volume. Here's my work. I got 8 cents an ounce for product 1. I did my division over here and I got 7 cents an ounce. Whew, pretty close. So which one would you go with and why? Yeah, I'd go with this other one because it's 1 penny cheaper per ounce. And every penny counts, right? Okay, let's take a look at a rate or a ratio table because again, it's another tool that we can use to organize equivalent rates. 2 burritos cost $14. 4 burritos would cost how much? Yeah, just double it, $28. Okay, now in this table, I have to figure out the cost for 5 and cost for 10. You might have a different strategy. What I'm going to do is I'm going to take what I know about 2 burritos and scale it up to 10 burritos. How many times greater is that? 5? That means the price is also 5 times greater. So $70. Wow, 10 burritos, $70. And now, how would you find the cost of 5 burritos? If I know the cost of 10, then I'm just going to cut that in half to know the cost of 5. $35. Now, the unit price, let's see it. We use division, right? The dollars per burritos. Dollars divided by number of burritos. 14 divided by 2 is 7. Maybe you already used this strategy to figure out the other ones. I don't know. That's a strategy, right? Why not? $28 divided by 4 is also $7 a burrito. Guess what? All the unit prices here are 7. These are all equivalent rates because they all have the same unit price. So you're going to take all of this great information and I'm going to ask you to explore the idea of rates. You're going to be able to identify equivalent rates. Again, apply your equivalent fraction knowledge. And then you'll be able to calculate unit rates and unit prices. I hope you find the activities fun, and I can't wait to see your work. Happy learning.